Here's the last mini lecture in this unit about random values, variables, and expected values. Um, so remember we talked in the last chapter about calculating the mean and the standard deviation, for example, as the mean as a measure of central tendency, where we would expect to see our data, and the standard deviation is a measure of dispersion, or how variable our data should be. So we want to apply this concept to these random variables that we've been talking about. So some of them come in grouped form, and some of them come in individual form. So when we calculated means before, we had a bunch of data points, and we added them all up and divide by n. Now what we're doing is looking at data where we have one value of something repeated over and over again, like the how many times do you sit down to dinner with your family in a week, right? Our values range from 0 to 7, but there were, maybe 11 people that said 0 and 100 and something that said 7. So we're going to use this particular formula that has a lot of notation, but basically all it means is you're going to take the value and multiply it by its relative frequency, and then you're going to add all those up. And you don't divide here because the relative frequency, remember, we get from the frequency divided by the total n. So that division by total n is already in the formula implicitly, okay? So you can see we've got the mean, the expected value of x, is the mean of x, and it is the sum of the values times their relative frequencies. Let's do an example. So, a respiratory virus is on the rise. How many boxes of tissues did your household buy this week? And the maximum number we got was 5, and the minimum number we got was 0. Okay. And so first we would need to know what the total is here. It is actually 7,600. I'm going to cheat and look on the next slide. So the total is 7,600. And let's get a pen. So the total is 7,600. And so the relative frequency of the first one would be 500 divided by 7,600. You can see that's on the next slide. And let's do 1 just for the sake of having 1. So that's 0.066. That's going to be close enough. We're going to say 0.066. And then what the formula says to do is to take the x and multiply it by that relative frequency. Now the x is, you have to remember, is the number of things, in this case the number of boxes of tissues. So we're going to multiply that by 5. And so that equals 0.066 times 5, 0.33. Okay. Now, if you want, you can pause this and you can work out the rest of it. But let's go ahead and look at it on the next slide. So there's our 0.33. The next one, the relative frequency is 0.033, and we multiply that by 4 boxes of tissues and get 0.132. And we're going to do that for all of them. Notice that because one of the values is 0, we can get the relative frequency here, and it's actually really high. It's the highest, highest of them all. But when we multiply that by 0, oops, come here, by 0, there we go, we still get 0, okay? Then what we do is we add all of those, so we get the total sum, and we get 0.968. So the mean is 0.968. Notice the mean has to be somewhere in the range of x values, and the range here goes from 0 to 5. The mean is almost 1. So that is in the range, so that's good. It's very small because most of the people, over half of the people actually, said 0. So it pulled the average way down. Um, why does it need to be in the range of the original x values? Like, why is that? Um, and that is because technically, it is a weighted average. Here it's weighted by the relative frequency. And so that's why it has to be somewhere in that range of original data. The variance and standard deviation for these is a little bit more complex, but it starts just like when we did the variance by hand before. You take each x value, and remember this is number of tissue boxes here. You subtract the mean, 0.968, and then once you get that, you square it, and then you multiply it by relative frequency. Okay, so you do something very similar to what you just did for the mean, but you have to go through all of that, computing deviations and squaring them. So for our first one, 5 boxes minus 0.968, the mean, the deviation is 4.03. We square that and get 16.24. And then we weight that by the 0.066 and we get 107. One thing to notice here, because now we're doing deviations. So remember the 0 line before gave us a 0 when we multiplied it out. But now we're dealing with a deviation, okay? And the squared deviation is not huge, but it's multiplied by a relatively high relative frequency. And so that contributes quite a bit to the overall variance, almost a quarter of it. At least about 20% of the whole variance. Okay, so once we get these numbers, again, we add them up. We add them up and get the sum, and that is the variance. So the variance is 2.23. To get the standard deviation, we're going to take the square root, and that gives us 1.49. One more thing. If we have a linear combination of random variables, remember we were talking about tossing coins and rolling dice and all of that sort of thing. So if we have a combination of things that each have their own mean and standard deviation, we can make linear combinations. So a linear combination is of the form a times x plus b times y, where x and y are random variables. To get the average of this combination, so we could say, where's my pen? We could say to get the expected value of ax plus by, that would be a times the mu of x, that's the expected value, plus b times the mu of y. And to get the variance, notice variances are squared things, so we'd have to take a squared times the variance of x plus b squared times the variance of y. And once we had the variance of ax plus by, the standard deviation of ax plus by is the square root of the variance of ax plus by. Okay, so this is really just some algebra, and it's just keeping track of what the a's and the b's and the mu's and the sigmas are. So here's an example. X is distributed with a mean of 5 and a standard deviation of 3. How do I know that standard deviation? Because that's just kind of the convention that we use, is that we do mean and then standard deviation, not variance. So y has mean of 12 and standard deviation 2.5, and we want to do a combination of x plus 2y. So there's an implied 1 here, right? If there's nothing there, there's a 1. So a equals 1, b equals 2. So this is a times mu of x plus b times mu of y. And so a is 1, mu of x is 5, so that's 5. B is 2, mu of y is 12, so that's 24. So that gives us 29. Okay? Now, remember for variance, we have to use variances. So we've got our a squared and we've got our b squared. But now we've got to take sigma and square it. And sigma and square it. This is a sigma y, this is the sigma x. Okay, so we've got 1 times 9 for this one, plus 4 times, oh dear, 2.5 squared. Hold on. $6.25. Okay, so that's 9 plus 25 gives us 34. That's the variance, and the standard deviation is the square root of 34, which is 5.83. Is your standard deviation. Notice that the problem is not usually getting the standard deviation, the problem is getting the variance. And there you go.